What will happen to Phobos and Deimos in Mars orbit? What happens to different body parts in space? Could Venus be a better destination for human exploration than Mars? Answering all these questions and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down. I'll gather them up and I'll answer them here. All right, let's get into the questions. Ninja Guy Dan, are Phobos and Deimos drifting away from Mars like our moon, or are they getting closer? So this is really interesting. We've talked quite a bit about how the moon is drifting away from the Earth, and this is caused by the tidal forces between the Earth and the moon. So if you imagine, the Earth has handles. It has like water that is bulging out from its sides. When the gravity from the moon is sort of pulling on the Earth, when the gravity from the sun is pulling on the Earth, then it causes the Earth to kind of warp a little bit. And then as the moon is going around the Earth, and as the Earth is turning, then these handles of the Earth, these sort of squished of the Earth, it's like a little bit, is sort of getting pulled by the moon, and the moon is attempting to slow down the rotation of the Earth. And as that's happening, then to sort of preserve the total amount of momentum in the system, the moon is drifting away from the Earth. And this happens because the moon takes about 28 days to go around the Earth. The Earth takes 24 hours to turn once on its axis. The Earth is turning faster than the moon is orbiting around it. And so what this gets you is the Earth's rotation slows down and the moon drifts farther away. But with Phobos, it's the opposite. So Phobos takes just shy of 8 hours to orbit around Mars, and Mars takes a little over 24 hours to turn once on its axis. And so you have the opposite situation where it's much faster for Phobos to go around Mars than for Mars to turn once on its axis. And so you get the opposite situation. So now Phobos's tiny gravity is trying to pull on Mars and speed up its rotation. And as it speeds up Mars's rotation, that causes Phobos to drift closer and closer to Mars. And at some point in about 50 million years from now, it will get so close, it'll cross within the Roche limit and it'll be torn apart, and Phobos will collide with Mars. And this is just the situation that you get, that if the moon orbits faster than the planet rotates, then the moon will drift inward. And if the moon orbits slower than the planet rotates, then the moon will drift outward. And of course, like, where are all the, Phobos is the only one, and it's going to be gone within 50 million years or so. You think about all of the other moons that must be out there, or that were formed since the beginning of the solar system, that had orbital speeds that were faster than the rotation speed of their planet. And they are long gone because they orbited in and crashed onto the planet. But Deimos takes like 30 hours to orbit around Mars, and so it's going to drift outward. War crimes. I heard that in space, your body becomes bigger. Does this extend to every part of your body? No. This just means that you grow a little bit when you're in space. No, this just means that you become a little taller in space. So it's the same thing that happens actually while you're going about your regular day here on Earth. When you lie down in bed, your spine is able to stretch out. And then when you get up over the course of your day, then your spine compresses down a little bit. And so you lose a little bit of height. And that's going to happen in space because there's no gravity that's holding you down, and you're going to sort of freely uncompress to your largest size. But also, like when you're on Earth, gravity is pulling blood down to your lower extremities. And when you are in space, you no longer have that gravity that's pulling the blood down. And so the fluids in your body redistribute. And so that can make your face very puffy. It can even cause fluid to collect around your eyeballs and cause problems with your vision. So There's a lot of problems with spaceflight that scientists have figured out solutions to. We know that your bones weaken, that your muscles weaken when you're in space. And it turns out that if you just do a lot of exercise, hours and hours a day of exercise, then you can overcome most of those problems. But it's this fluid redistribution problem that people don't really have a great answer for. One possible solution is that you would sleep in a sleeping bag with a negative pressure. And so it would be sort of like you'd be sleeping in a vacuum cleaner, and it would be attempting to bring the fluids from, where they've redistributed around your body down into your lower extremities. And that would help sort of fight that. And this is still an ongoing test. And if that works, then we're down to just a couple of issues, downsides of being in zero gravity for astronauts. In Bartles 87, if Venus were less harsh environmentally, would it be a better candidate for our first planet to set foot on instead of Mars? Is it easier to get to? Yeah, Venus would be an amazing planet for us to visit if it didn't suck. And it really sucks. If you're down on the surface of Venus, you are experiencing about 90 times the atmospheric pressure that you experience on Earth. It's the equivalent of you swimming down 1 kilometer below the surface of the ocean. Like, imagine, right? You're down under a kilometer of ocean. You're experiencing incredible pressure. When we've seen subs fail, that's what that's what you would experience. But then, not to mention, you've also got the temperature, which is more than 400 Celsius everywhere on the planet, no matter where you go. If you're at the poles, if you're at the equator, it's 460 Celsius, really hot. And so that's hot enough to melt all kinds of things that you might want to use. And so there's just no living on Venus. And so the question you're asking is, well, could it be, if it wasn't so bad, then could we go there? And it just kind of depends on how not bad you're talking about. If it had the same atmospheric pressure as Earth, Venus is the same size as Earth, or almost the same size. It's almost the same density as Earth. It is really a twin of the Earth if it wasn't so awful. It's closer to the sun, hotter, has this higher pressure, this carbon dioxide atmosphere, rains sulfuric acid. It's not great. But if you could go and just tinker with various aspects of Venus, change its atmosphere so that it has an atmospheric density of Earth, has a oxygen, nitrogen composition like we have in our atmosphere, that would be amazing. Imagine if you could bring those temperatures down. If you have liquid water on the surface of Venus, then it would be a really intriguing place for us to try and go and visit. In fact, for the longest time, science fiction authors wrote about Venus as this sort of hot, steamy jungle world that they assumed, the thick cloud tops on Venus just meant that we couldn't see, it was eternally in these clouds, but actually it was very much like a jungle down at the bottom. And it wasn't until the Soviets started trying to land spacecraft on Venus, the Venera program, where the spacecraft died one after the other, that they finally realized just how awful it is down there on the surface of Venus. So the second question then is would it be easier to get to than Mars? And not necessarily. So the delta V that's needed, the change in velocity to go from Earth orbit to Mars, and the delta V required to get to Venus is roughly the same. It's about 5.5 kilometers per second. Generally, it's pretty tricky to get to planets that are closer to the sun in the solar system. But it's also pretty tricky to get farther away from the sun, to climb out of the gravity well, to get out into the outer solar system. And a lot of times, missions will use the inner planets for doing gravitational assists. So we've seen that ESA's JUICE mission did a flyby of Venus, is going to do a flyby of Earth, is maybe do, you see missions do multiple flybys of inner planets. So if we wanted to send a human mission to Venus, it would be about as difficult as sending a human mission to Mars. But if you had this thick atmosphere, like the Earth's atmosphere, then it would be much easier to land, because, this is the big problem with trying to land heavy payloads on Mars. It has a very thin atmosphere. It's too thin for you to be able to do a really proper atmospheric braking in the way that you do on Earth. And so if you just sort of come in and try to use the atmosphere to slow you down, you'll crash onto the surface of Mars. But it's too thick to do this propulsive landing in the way you might land on, say, the moon, where there's no atmosphere. You sort of really nicely, easily put yourself into a propulsive landing and you land. It's sort of like right in between. And so it's actually been pretty tricky to land heavy payloads on the surface of Mars. But if you had a thick atmosphere to do an atmospheric entry into, like Venus, then that would be a lot easier. It's funny. So with Venus, the atmosphere is so thick that when the Veneer spacecraft sort of come in, they don't really have to think about landing. They are sort of, it's more like you're dropping a rock in water, they just sort of slowly sink down to reach the surface of Venus. So it's a totally different situation. They had to deploy a parachute at the end, I think, but it's very easy to land on Venus. Just, you don't want to land on Venus. If you want to support the work we do at Universe Today, consider joining our Patreon club. Your support lets us have a minimum of ads and no sponsorship messages. Patrons get no ads on universetoday.com for life. Want the extra parts of the live stream that aren't in this edited version? You can sign up for a special patron-only podcast feed and get the overtime segments, as well as other special behind-the-scenes episodes, including our monthly patron-only question show. Thanks to everyone who has already subscribed, and welcome to our recent newcomers: Frogboy, Russell Breyer, Technomatic, Bear Lemley, Natai Flick, Shoot Z234. Join the club at patreon.com/universe today. For Natya, do you have a favorite moon? I don't have favorites for almost anything. But I do have a bunch of moons that I really like for different reasons. So I think my favorite right now is Titan. And that's just because it's such a cool moon of Saturn, right? It's one of the largest moons in the solar system. It's like the second largest after Ganymede. It has an atmosphere that's 1.5 times as thick as Earth's atmosphere. And so you could walk around on the surface of Titan without having to wear a spacesuit. Now, you would still have to wear a breathing mask because the atmosphere is, not breathable for us. And it's incredibly cold. So you would need to have like an Antarctica coat on that would keep you warm in that kind of a temperature. But then you would be able to walk around on Titan. It would be kind of amazing. But we know that there are seas of liquid methane on the surface of Titan. It rains methane. And it's believed that, on the surface of Titan, you've got this atmosphere, you've got this surface where it's like the ice has become the mountains. The ice is the rock on Titan. But then it probably also has a liquid water ocean that is underneath the ice. And so it's sort of got everything. It's got hydrocarbons on the surface. It's got water underneath. It's thought that the kinds of chemicals that they're going to find on Titan are very similar to the kinds of chemicals that we might have had on an early Earth. So it's just a really exciting place. Enceladus is probably another one of the candidates that I'm really excited about. Of course, we know that it's got these tiger stripes at the bottom of this moon that are blasting water ice out into space, and that based on Cassini observations of this water ice that's going out into space, we know that it has dissolved hydrogen gas in this water. We know that it has various kinds of other chemicals, kinds of things that life might need. And because it's being thrown out into space, it should be relatively easy to be able to sample the stuff. It's probably the best place for us to search for life in the entire solar system. Better than Mars, better than Europa. Enceladus should be our number one priority. And then just for like crazy weird moons, I really like Iapetus, which is another moon of Saturn. So I guess I've just picked moons of Saturn. Now, Saturn is my favorite planet, so I think it makes sense. But Iapetus is this really strange yin-yang moon where one half of this moon is bright white and then the other half of the moon is very dark. And it's believed that it ate a ring which made it white on one side. So it's a pretty cool moon. So I'd say those are my sort of 3 current favorites right now. But then I really like Triton orbiting around Neptune. Yeah, don't make me choose. Francis Tony, when did it become okay to look for aliens as a scientist? Are there currently any taboo subjects for an astronomer? So this is a question that I'm actually really fascinated with. And so there was a conversation that I had with an astronomer a couple of years ago. And this exact question came up where I was saying, why were astronomers not able to get funding for projects like SETI and things like that? And fairly recently, this has sort of turned around. And now, in fact, NASA is funding technosignature searches. There's actually some funding for people to be able to go out and look for aliens. And, he was saying, it was Jason Wright. And he was saying, it's kind of funny, for the longest time, we were like, it's okay to look for dumb aliens, but why isn't it okay to look for smart aliens? And I'm researching this right now. This is my current obsession. What was the chain of events? So if you go all the way back to like the 1950s, the 1960s, you had Frank Drake with Project Ozma, where he started to propose that we listen to various stars with giant radio telescopes to detect the signals. And then you got this kind of giggle factor for a while there where people said, well, that's ridiculous. We're not going to look for aliens. And so there was no funding for SETI. And so there was this sort of dark period in the 70s and the 80s and the 90s where anyone who wanted to do research, and especially the people at the SETI Institute, they had to find their own sources of funding that didn't come from the government. You couldn't get National Science Foundation funding or NASA funding or things like that. And then in the 1990s, scientists started to find extremophiles here on Earth. So they found bacteria in hot springs. They found bacteria in nuclear reactors. They found bacteria high up in the atmosphere, 10 kilometers below the Earth's surface. And people started to realize that life was everywhere. And when you think about the fact that, wherever we find liquid water on Earth, we find life. And they realized that, well, there's lots of places that there could be liquid water around the solar system. So it makes sense for us to start looking for life on other worlds. And this created the field of astrobiology. And so now you got astrobiology. And so people are saying, like, what are the different ways that we could search for evidence of biological signatures? Well, along comes exoplanetary astronomy, and astronomers say, well, the next generation of telescopes like James Webb are going to allow us to look at these other planets, detect the atmospheres of these planets, and maybe measure the presence of the kinds of gases that some sort of life is going to be producing into this atmosphere. And then some astronomers said, well, couldn't we also look for things that advanced civilizations would be producing, like chlorofluorocarbons, or if they're having nuclear wars, or if they're in the middle of the industrial age? And the answer is yes, that James Webb is capable of detecting chlorofluorocarbons around planets orbiting around various stars. Like if there was an advanced civilization on the TRAPPIST-1 worlds and they were producing chlorofluorocarbons, James Webb could detect it. And now you kind of can't deny that searching for aliens, searching for technosignatures is a legitimate way to search for biosignatures, to find out if we're alone in the universe. And so it sort of had this really long and really fascinating journey. So that's a story that I want to tell. And I'm sort of thinking about how I'm going to actually tell that story. So thank you for bringing that up. Cap Bia, why do most science communicators talk about an interplanetary future when it's becoming ever clearer that we will never achieve that? What makes you think that we will never achieve an interplanetary future? A lot of people think that I am, unnecessarily skeptical about humanity's future in space, that I poo-poo the idea of us building a city on Mars, or us building a city on the moon, or us doing asteroid mining and all that kind of stuff. And I really want to set the record straight. For me, it's just about time frame. So, do I think that we're going to have a city on Mars the way Elon Musk and other big fans of Mars space exploration? No, I don't think we will have that by the end of by 2100. But humanity's ability to go out into space is on an exponential curve. We are developing better and better technology, and that, eventually it's inevitable that we will become an interplanetary species, or we'll be dead. And maybe that's what you're saying. Maybe you're cynical about the future of humanity, and so you don't think we stand a chance of doing anything, that we're just going to wipe ourselves out and it doesn't matter. And like, obviously that's a possibility, that humanity's story will come to an end at some point. But I am a lot more hopeful and optimistic about our future. And so for me, it's not that I think we won't have that kind of a future. I think it's inevitable that we will, as long as we survive, that our technology will increase, that we will eventually trivialize the kinds of things that it takes to travel to and live in space, and that more and more of humanity will be living various places around the solar system. I just have a longer time horizon. Like, I just think that's the kind of thing that we'll be doing 200 years into the future, not 30. But yeah, I think, like, fundamentally, if you go back and look at the rise of our, just total energy use, gross domestic product, the amount of resources that every human being has, available to them, these are on exponential growth curves that are going up by a couple of % per year. And if you just chart that forward, within a couple of 100 years, the only way is if we are spanning across the solar system, using a lot of the resources across the solar system. You keep running that forward, the only way is that we've created a Dyson sphere. So, humanity has had this growing use of energy and capability for its million years that it's been around. So I wouldn't bet against us continuing this growth. All right, those are all the questions that we had this week. Thank you, everyone who put your questions into the comments on YouTube, and especially everybody who joined for the live stream, which we do every Monday. The time changes depending on which part of the planet we are targeting. But so definitely check the upcoming schedule to find the show that's going to be right for you. Now, I'm going to give a big thanks and let you know a little bit about what our plans are for 2025. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Andrew Gross, Bear Lake Roofing, David Gilton, and David Matz, Dennis Alberti, Dustin Cable, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Paul Rohrbach, Sean Sargent, Spiderswept.io, Stephen Fowler Munley, and Vlad Chiplin, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. Well, we are nearing the end of 2024, and that means that we are now going to go into 2025. And, we've got some big plans, ideas for content, for new streams. We're going to be doing a lot more of the telescope streams, a lot more really interesting interviews, a lot more special projects that we're working on. And the thing that makes me so excited, the thing that I am looking forward to, is shutting off advertisements on the Universe Today website. And, we can't do it today, but I feel like we are 4 to 6 months away, as long as more people still come on as patrons, to get to this point where we can actually shut off those ads. And when that happens, then we are 95% covered financially by patron. And that's it. Just thousands of individual space enthusiasts who have decided to support the work that we do, to support the salaries of all of the journalists that we have on Universe Today, to support Anton, Chad, our video editors, producers, and of course, me. And when that happens, then we will be kind of bulletproof. We're no longer going to have to wait and see what kind of strange things Google does with artificial intelligence and how they try and take away search engine traffic because they're just scraping content and replacing it with their own on Google itself. You don't have to worry about Facebook algorithms changing the way they plan to do things. It's just going to be me trying to create the best possible space journalism and reporting for you, the fans of space journalism and reporting. It seems surreal, and yet I feel like we're very, very close to doing this. And I think when I do it, it's going to probably be a little early. We'll be a little lean. We'll have to be very careful about how we handle our spending. And at the same time, the freedom and sort of lack of fear of us running afoul of an algorithm or whatever feels really liberating. And in a time when journalism is under attack from every direction, this seems really exciting. And so if you want to be part of helping us get there, shorten the number of months it'll take, please join our Patreon. But even if you don't, I hope you get as much value out of this content. It helps, increase and improve your awareness and excitement for space and astronomy and space exploration. And I will see you in 2025.